Okay, good morning, everyone. Today, can you hear me? Okay, so welcome all of you back to Physics 1. Okay, so now I will share my screen to all of you. Okay, okay, let me see. Okay, now we discuss a little bit the timetable of Physics 1. Okay, so for up till now, we 1, 2, 3, 4, 5, 6. Okay, so up to now, okay, including today class, okay, we have studied 6 classes. Okay, so for this course, we have totally 12 classes. Okay, and anyway, I will come back to Vietnam uh, next week. So let me see. So we will study on site on other classes. Okay. Yeah. And please remember, if you cannot follow the lectures, okay, yeah, you can go to the YouTube channel, and then you can rewatch the video, the lecture recordings. Okay. Yeah. Because some of you study very well for physics 1 or linear algebra, and the other ones maybe need more time to understand the lectures, but that's okay. We have video. Okay, you can study for yourself, of course. Okay, you attend my class and then you study for yourself at home. You can improve your knowledge. Okay. Anyways, okay, see you at the VGU campus, okay, for New Year's. Now we continue to study lecture 2, part 2, and we hope we can finish this lecture in this morning. Okay. And today, please help me to make a recording now. Okay, so we need to review a little bit. Okay. So the last lectures we discussed about displacement, right? We have x. Yeah. And x or sometimes we say r. Okay, this is position or displacement. Remember, when we consider displacement, that means you should have the coordinate. Okay, the coordinate. So normally this one is times x-axis is a times, and y-axis is position. Okay, position. Next one we have d. This is distance. Okay, when we mention about distance, we don't care about the starting point or destination point. Okay, because the distance mean a length of the path. Okay, the path. We also mention about v, velocity, and we just consider one direction. Okay, or we say straight motion. Okay, for one direction. Okay, so if we have one direction, normally we consider is x-axis direction. Okay, for x-axis, this is minus infinite. This is positive infinite. Okay, so if we have the velocity vectors in this direction, that means positive. And then if we have the velocities in this direction, this is negative. Okay, yeah. So it depends on the moving of the object. Okay, we can get the positive direction of the velocity or negative direction of velocity. Okay, so of course this one is the vectors. Okay, we have velocity vectors. Okay, we also have average velocity, and we have instantaneous velocity. Okay, yeah. So to calculate the velocity for instantaneous velocity, we have vxe derivative of x with respect to time. Okay, or we calculate limit. Okay, yeah, and delta t is 0. Okay, yeah, delta x over delta t. Okay, yes. Okay, what else? And of course, we know how to calculate average velocities. Okay, we have Vx. Normally we say average. Okay, average. This is we have delta x over delta t. Okay, and delta x is xf minus xi over tf minus ti. Normally at the beginning ti is 0. Okay, so we have xf minus xi, and because ti is 0, so tf mean delta t in delta t. So we have xf minus xi over delta t is vx average. Okay. What else? And we have some examples. Okay, we also discuss about acceleration. Okay, ax. Yeah. Of course, this is the vectors, and we also follow straight motion. Okay, for example, we have x-axis. Okay, and then if we have the acceleration vectors like this direction, okay, this is positive, or we say a positive, and here you get a negative. Okay, yeah, because this is minus infinite, this is positive infinite. Okay, and we also have instantaneous acceleration, and we have average average acceleration. Okay, so to calculate the instantaneous acceleration, we have axe dvx over dt. Okay, yeah, or we can calculate by limit. Okay, of delta t is approaching to 0, delta v over delta t. Okay, or you can calculate ax average. Okay, this is vf vf. Okay, this is final velocity minus initial velocity over tf minus ti. Okay, or you can guess delta v over delta t if ti is 0 and tf is delta t. Okay, because ti is 0, right? Ti is 0, so tf equal delta t. Yeah, so this is the basic knowledge we study maybe last 3 weeks. Okay, so now we continue. Yeah, so now we have some review questions, okay, to have you remembers the knowledge we studied before. Okay, so here we have a mic. We have a mic zoom out of a tree and lands on the timberline here. Okay, so the timberline sags, okay, 2 feet before launching. Mic back into the air. So at the very bottom here, okay, where the sharks is the radius, yes, of course. Okay, mic acceleration is upward, downward, or 0. Okay, because when he out, okay, after some times, okay, his moving will be stopped. Okay, so to let him stop, the acceleration must be going up. Okay, yeah, so yeah, the answer is upward. Yeah, next one, we have a cart slow down while moving away from the origin, so they give us the information of the origins. So what do the position and the velocity graphs look like? Okay, so that means we have position versus times, right? This is times, this is 0, this is 0, and this is position x or r. Okay, and we also have another graph. This is times, and this is vx. Why we say vx? Because this object is moving in the straight motion, in the straight line. Okay, only one direction. Okay, so here is 0. Yeah, so for this question is very clear because we know where is the origin. Okay, yeah. Okay, so now you have 1 minute. Okay, try to think about your answers. Okay, because we study online, so I cannot give you more extra point. If you join the link online, I mean, many people maybe we get this congestion. So please just think about your answers, and then we double check with the reference answers in the lecture. You know, a car slow down. This is the key words. Slow down. So that means, I mean, after sometimes the car will stop. Okay. Okay, time's off. So we need to check the answers. Okay, so the correct answer is this. It's very easy, you know, because you can see at the beginning, you know, the car will be here. So for x will be 0, xi is 0. Okay, so after sometimes you get xf. So xf is higher than xi. So for the curve like this. Okay, and you know, after sometimes the velocity is 0 because the car slow down. Okay, and then stop later. So, okay, so at the beginning here is vxi, sorry, vi. This is vi, right? Yeah, you just say this is vi, and somewhere here is vf. Okay, so I think the key point is you need to determine where is the initial point and where is the final point. Okay, after that we identify xi and xf, vi and vf, vi and vf. Okay, yes. So at the beginning, that means this is ti and this is tf, right? This is ti, this is tf. So the positions will be the position will be positive because follow this direction, you know, positive. And the velocity is also positive because they also have the same direction with the position. Okay, so at the beginning vi is the highest values, and then after some time ti to tf. Okay, you get a 0. Okay, this is vi, this is vf, this is xi, and this one is xf. So the correct answers will be here. Okay, this one is wrong, you know, this one is wrong because at the beginning, okay, at the beginning at the origins, okay, x is not here. Okay, and vx is negative is wrong because we follow this direction, vx should be positive. Okay, and this one is wrong. Okay, this one is wrong. Okay, so the correct answers will be question D. Okay, any questions so far? Okay, so no pictures. Next. Continue. Now look at this one. A car speeds up, you know, speeds up toward the origins. So what do the position and the velocity graphs look like this? Okay, yeah. And then, you know, if we follow these directions, you get positive. Okay, so if we have these directions, you get negative. Okay, so at the beginning, somewhere here, this is initial position. And here, so the origins will be the final position. Okay, yeah. And remember, the car will speed up. Okay, speed up. So speed up, that means the velocity. The absolute values of the velocities will be increased. Okay, so now you can draw the curve. This is x, this one is t, this one is x, this one is t. But now initial point here, okay, and the final point here. Okay, so here you get ti, here this is tf, here ti, here tf. Actually no, because this is we follow the time axis. Okay, so just say here is let's say here is ti, and this one is tf. Ti is tf because this is the time axis. Okay, this is x. Okay, this is distance. Okay, so here should be ti and here should be tf. So this is initial position, this is final position, initial position, final position. Okay, sorry. So at the initial position, we have some values of x. Okay, and after some times, the car will come to the origin. So if the car comes to the origin, x it will be 0. So we think this one. Okay, because at the beginning we have some distance, right? We have xi, and then when the car moves to the origins, okay, the x will be 0. So we think about this curve. Okay, so if you think about this curve, we can delete this one, we can delete this one, because at the here, look at the beginning, x is 0 is wrong. It's wrong at the beginning here. So we have some values of xi. Okay, xi here. So we have this one and this one. Continue. So now we consider the velocity. The velocities, speed up. So at the beginning, imagine that. Please imagine at the beginning when we start, the car motion. Okay, of course, v's xi will be 0 at the beginning, right? And then if we consider the direction, okay, we mentioned before, if we come to the right side, you get positive. If we come to the left side, you get negative. Okay, so if we consider this one, okay, the cart is moving to the left side. Okay, so we know Vx is negative. Okay, this is also negative. This is also negative. But at the beginning, Vi is 0, right? And then when the car comes to the origins, with the absolute value of Vx of velocity will be increased, so you get this curve. Okay, yeah, and this one is wrong. Okay, so the correct answer is C. Okay, and I hope you enjoy it. Okay, any questions so far? So now I give you some steps. Okay, the first step, any motion, we need to follow the coordinate. Okay, if we only have one direction, this is positive, this is x-axis, right? And this is negative. Okay, come to this way, we get positive. Come to this way, you get negative. Okay, if they follow y-axis, okay, of course only one direction, but they follow y-axis. So this one is positive, this one is negative. Okay, this is the first step. The second step, you need to know where is the initial position, where is the final position. Okay, and then we also consider the speed, increase or decrease. Okay, yeah, you can, or and the distance and displacement. Okay, displacement. Okay, this is increase or decrease. Okay, you can draw the curve like this. Okay, so this is some tips for you. Any questions so far? If you have any questions, please ask TA, and then TA will repeat to me, or you can type your message, okay, into the chat room, and I can read it and I will explain to you. Okay, let me check. Okay, are there any questions so far? Okay, good. Continue. Yes. Now think about this one. Think about these questions. Okay, I will explain to you a little bit. Okay, so we have a card speed up, also speed up. Okay, while moving away from the origin. Okay, so we know this one is original, or sorry, this one is initial point. Initial point, and somewhere here, this is the final point. Okay, yeah. So what do the velocity and the acceleration graphs look like? Okay, they ask us to draw the curve of Vx, because this we follow the straight motion, right? And what's Ax? Okay, so remember that if we apply the first steps I mentioned before, you know, the motion of the object is going to the right side. Okay, so positive. Okay, Vx is positive, Ax is positive. Okay, positive. So if we have negative, you can delete it. Positive, 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 positive. Okay, all answers. Okay, all answers, yeah, are positive. So yeah, you cannot delete anyone. Okay, so that is the first step. Okay, the second step. Okay, we need to consider initial point. Initial point here. So of course, Vx will be 0 at the beginning, right? Yeah, I mean the Vi at the zero at the beginning. Vf is some value. Okay, speed up. So speed up doesn't mean Vf must be higher than Vi. Okay, so look like this one. Oh, that is stupid, right? Because Vi and Vf is similar, are similar. So skip it. Okay, so we can delete question I. Sorry, answer 8. Now answer B. Oh, interesting, you know, because yeah, so Vi is 0, and after some time Vx is positive. Okay, so correct. So now we have C, B, C, D, correct. Okay, so look, this is linear. This is linear curve, right? Linear curve. So what does it mean linear curve? If you study the linear algebra, y is ax plus b. Okay, and of course x is variable, a and b are coefficients. Okay, so now we have v. Oh my God, sorry. So now we have v e a x plus b. Okay, that means v is the linear curve. Okay, so when we take the derivative of v with respect to t, I mean the first order derivatives of v with respect to t, you get a. Okay, so here is Vx, here is x. Okay, so when we take the derivatives, you can get a, that means constant. So Ax must be constant. Ax must be constant because it's a linear curve. Okay, but now look, Ax is not constant. Okay, skip it. AX is not constant. Skip it. So the correct answers will be B. Oh, yes. Okay, this is B. Do you understand? Okay, so now we have TI, TF, TI, and here TF. Okay, you get AX like this. This constant. Okay, I hope you enjoy it. Any questions so far? Okay, no questions. Continue. Eh, we also have some uh, multiple choice questions. Okay, so here is a motion diagram of a car. Okay, speed it off. Okay, speed off on a straight road. Okay, look, this is origins. This is origins. Okay, so if we come to these directions, you get positive. Okay, we mentioned before, this is first step, the first step. And if come to this direction, you get negative. Okay, so now look, the initial position here. Okay, and okay, after some time, this is the final position. Okay, and when we observe, okay, you can see the velocity increase. Okay, speed up, speed in up. That means the velocity, I mean absolute, the velocity is absolute. Okay, so if we don't know what is the direction of velocity, we just consider absolute values. So absolute value is increasing, right? Increasing. Okay, so if we consider here is Vx, here is times. Okay, and we also have Ix and times. This is Ti, this is Tf, this is Ti, this is Tf. Okay, look, this is times Ix times Vx. Okay, so at the beginning, of course, the Vi is 0 at the beginning. Okay, and then after some times, okay, velocity increase, so here is Vf. But remember, if we follow this direction, that means negative. So we get Vx like this. Vx like this, because this is negative and this is Vf. Okay, Vf is negative. Vf is negative because because the car is following the direction, the left side direction. Okay, so remember this is negative. Okay, so how about Ix? So if Vx is negative, that means Vx is minus Ix plus B or minus B. Okay, but this is should be minus because negative, right? Or we say Ix mean time, right? This we get a minus It plus B, sometimes like this. Okay, yeah. So when we calculate Ix, a dVx over dt, you can get a minus A. So the velocity should be, sorry, the acceleration should be here. Okay, A is negative. Okay, and sorry. So for this is Ti, this is Tf. Okay, so A is negative, and then you come to the answer here. Okay, the side of the acceleration Ix is negative. Okay, now, yeah, Splitting off means Vx and Ix have the same size. Okay, just the same sign. You know, if Vx is negative, Ix is negative. Okay, so now we have the observation. We have the observations from here. Look, if Ix had the same direction with Vx, I mean the same direction, you know, maybe positive or negative. But if they have the same direction, that means splitting up. So if Ix difference Vx, we have slowing down. Okay. Yeah. So this is the observation, very important, you know, very important. So if Ix E similar to the direction of Vx, speeding up. If Ixe different from Vx, okay, slowing down. Okay, or speeding down. Okay, any questions so far? Let me check. Any questions? Okay, no questions. Okay, no questions. Continue. Continue. Oh, now a lot of questions. Oh my God. Okay. Hey, the same. The car slowed down while moving away from the origin. Okay, what do the velocity and acceleration graph look like? So this one, I remember like this ones. Slow down. Yes, the same, you know, the same. So very quickly, Oh, but this one is Vx and Ax, sorry. Okay, so just 1 minute. Think about this one. Okay, we draw velocities and acceleration. Okay, the car slow down. Okay, so now we have x, sorry, Vx, and we have Ix. Okay, so look, this is Ti, this is Tf, this is Ti, this is Tf. Okay, this is origins. Okay, and then you should remember, if we follow these directions, you get positive. Okay, and if you follow these directions, you get negative. This is step 1. Step 2, we need to analyze. Okay, so the car slows down. The car slows down while moving away from the origin. So at the beginning, this is initial. Hey, sorry, it's some, you know, some yeah, my laptop is not good, so yeah, so the running is slow, so I need to open again. Okay, so now we have initial point. Okay, and somewhere here, this is the final point. Sorry, I don't know why it's my laptop is okay, good. Okay, so now look, slow down. Eh? My letter is very stupid. Okay, anyway, so here, you know, at the beginning, you know, slow down. So after some times, Vx will be 0 because slow down, and Vi should be positive, you know. So Vi should be somewhere here. Okay, and the Vf must be 0 after some times. So you can get this curve. Okay, slow down. Yeah, so we can delete this ones because at the beginning vi is 0. No, because this is slow down. So no, that means we have some initial velocities to be different from 0. Okay, so we delete this one, we delete this one. So only this one and this one. Okay, correct. Correct. Now we consider Ix. Okay, so because this is slow down, this is slow down. So if we consider this slope, so Ax must be like this, you know, we consider this slope. Okay, so if Ax like this, that means they come to the fourth quadrant. Okay, so Ax should be here, right? Because this, you know, we have for the first quadrant, we have the second quadrant, we have the third quadrant, and we have the fourth quadrant. Okay, so if we have this slope like this, so Ax must be here. Let me check. Okay, but if we explain like this, it's wrong because actually if Vx is constant, Ix is negative, that's okay. But now Vx is positive, okay, and Vx is slowing down. So I think that's okay. So for now, we should have Ix should be negative, right? Ix should be negative. Because we mentioned before, Vx is different from Ix. Okay, you guys slow down. So if we move Ix to the fourth quadrant, okay, so Ix is somewhere here. Okay, so the correct answer should be here. Question C. Okay, so we delete this one. Now we get the correct answers here. Yeah, correct. Or we can explain like, let me see. You can explain like this. We have V is, let me see, V I is Vf minus Vi over Tf minus Ti. Okay, and then you can see Vf is 0 and Vi is some negative, you know, maybe some negative. Okay, divided by Tf minus Ti. For example, Ti is 0, you can get a Tf. Okay, you can get minus Vi over Tf. And then if we observe this one, okay, this is minus. That means Ix different from Ix. Vx different from Ix. So here. So anyways, let me see. It's up to you. Okay, you can apply the formulas. We can apply the formulas. I mean these formulas to determine the direction of the eye. Or if you are familiar with the graphical representation, you can explain like this. Okay, this is method one. Okay, and this is method 2. Let me see, we have any other methods? To determine the acceleration. Okay, so for or if you this is method 3. So if you understand this one, okay, like the observation we discussed before, okay, you can get very quickly the results, the answers. Okay, so this is method 3. So it's up to you. Okay, yeah, you can use graphical representation or the formulas or to the observation. That's okay. Any questions so far? Guys, are there any questions in the class? Okay, so if we have no questions, continue. Okay, now we have 1 minute. Try to give your answer and then you inform to TI. Okay, you inform to TI, and then TI will count 3%. The first 3% get the correct answer. You get 1% extra point. Okay, 2% extra point. Okay, come on. 1 minute and 3%. 3%. Or TI can randomly choose 3%. That's okay. It depends on the TI decision. Okay, so we need the first 3% to get the correct answers, and then they will get 2% extra point. After that, I will input the extra point into the Excel, okay, into the Excel file, and I will know, okay, I will count when we have the final exam, okay. So for 1 minute. Okay, time off. So yeah, so now I will explain these questions for you. Okay, very slowly, but for the final exams, you just have some minutes try to get the correct answers. But now for the lecture, so very slowly. So now we need to determine Vx times Ax times. Okay, so at the beginning, look, our car speed up, okay, while moving toward the origin. So what do the velocity acceleration graphs look like? Okay, so this is Ti, this is Tf, this is Ti, this is Tf. Okay, so at the beginning somewhere here, right? This is initial. point. And while moving toward the origin, so the origin will be the final point. Okay, and then I also explained to you, right? We should determine positive and negative direction. Okay, so this is your origin, right? So if come this way, you get positive direction. If come this way, you get negative, right? So the speed up, so at the beginning, vi should be 0 because at the beginning, we start. Okay, we start to have the velocity. So vi here. Okay, so we can delete this one, right? Because at the beginning we have some value of velocity, and after that, this is slow, this slow down, not speed up. Okay, so delete this one. Okay, and then after some times, the velocity is increased. I mean, the absolute value is increased. Okay, but remember this direction. This direction is negative direction. Negative direction. So after some times, VF should be here. VF less than 0. Okay, so we can delete this one. So this one correct. This one correct. Now look, method 1. Step 2. Step 2. Method 1. Method 1. Method 1 is what? We consider the slope, right? We consider the slope. We consider the slope. Look, this is the slope. This is the slope. This is the slope. Okay, and this is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Okay, so if you so this is the fourth quadrant. Okay, yeah, so Hx, the slope is constant following the time. It's constant because velocity is linear, so I is constant. So we can get Ix like this. Ix like this. Okay. So, we can delete this one because Ix is positive. So the correct answer is C. This is the method 1. Now let me see. Let me think. We have the method 2, right? We apply the formula, right? We have IE VF minus VI over TF minus TI. So TI is 0, so you get the TF is positive. Okay. Now VF is negative. Maybe minus I, something like that. And VI is 0, minus 0. So you get minus I, right, over TF. So you get minus. Okay, minus. Okay, then let me see. Method 1, what's in method 3? Method 3 is we have the observation. Okay, so method 3. If we remember the observation, we have Vx is the same with Ix. You get speed up. Vx different Ix. Speed up. Okay. Now speed up. And then Vx is negative. Vx is negative, right? So Ix is negative. Okay. So the correct answer will be C. Okay. Congratulations, 3 persons. Okay. Yeah. Any questions so far? Any questions so far? Bautan, are there any questions for the class? Any student guess actual points? Okay, good. Thank you so much. Okay, continue. So very easy, you know. Yeah. And now, oh, we also have questions. Okay, but I think this one is easy. Okay, so I will explain to you. Okay, no extra points for these questions. Okay, so which the velocities versus times. Okay, vx times. Okay, rough goes with this acceleration rough. Okay, they give us the acceleration. Okay, so from now we consider this is the first current, the second current, the third current, and the fourth current. Okay, yeah. So from now we know AX and we need to refer to VX. Okay, so this one, you look, this one is negative, right? This is negative. This is positive. So this is positive infinite. This is negative. But this is negative. This one is positive. Okay, so if AX is negative, okay, we have the VX curve like this, right? This is VX. Because if the Vx like this, we have the acceleration. Okay, we have the acceleration. We have this slope. Okay, this we have this slope like this. Okay, so this slope like this mean the forward current. Okay, so if we have negative and Ax is constant, of course Ax is constant and negative, Vx curve should be like this. Should be like this. Okay, and now look here. Ix is constant, right? Ix is constant. And positive. Positive does mean the fourth current. So Vx must like this. Because if Vx like this, we have the slope. We have the slope. We have the slope like this. Okay. If the slope like this, you can move to the first quadrant. Okay. So the V, if we combine, if we combine, let me see. If we combine this one and this one, okay, you should get the curve like this. Okay, and now you can check the answers. Oh, stupid, right? Oh, stupid too. It is stupid. Okay, now we need to carefully consider this one and this one. You know, this one is upward. This one is downward. I mean the peak of the triangle. Okay. Now, if you consider this one, this is the first. Yeah, this is the for current. So should be like this, right? Should be like this. Okay, and this one should be like this. So the correct answers will be E. Okay. Yeah, that's all. Do you understand? 1 or 3 minutes for question and answers. Okay, you know, yeah, I hope you are very familiar with graphical representations because next semester you will study the physics 2. We study some basic courses, and then you know how to draw the vectors or electrical parameters. Okay. Any questions so far? Okay, so if no, let me check. Let me check. Are there any questions? Okay, good. I think physics one's course is very easy. Okay, all of you can understand. Okay, so we finished. Okay, so now we have the exercise, and now extra boys come in. Okay, now I need 3 persons. Okay, to get the correct answers. The correct answers for ABCD. ABCD. Okay, now each of blah blah blah. Okay, just we need to determine. Okay, each of figure they show us the position, velocity, and acceleration. This is position. This is velocity. This is acceleration. Okay, for each figure indicate whether the distance. I mean the distance okay, from the origin to the objective increasing or decreasing, and the speed increasing or decreasing. Okay, we have two answers for every figures, right? For every figure. The first of all, we need to determine the distance that is increasing or decreasing. The first, oh, sorry, oh my god. So, and the second one, okay, the speed is increasing or decreasing. Now, 1, 2, 3, 4. 2 minutes, 3 minutes, 3 minutes for 3%. Okay, come on. And I to continue to select 3 persons. Okay, yeah, 3 minutes now. Come on. Good luck. Okay, time off. Let me see. So, are there any questions so far? Okay, no. Now, answers. Now, answers. Okay. So, maybe we check the answer first. Ta-da! Okay. So, now, T8. Okay. Double check the answers with this one. Okay. Now, I will explain to you. So, I think, let me see. For the simplicities, I just explain to you based on the observation. Okay, because we don't have more time to draw the curve. Okay, so I just use the observation. Okay, to explain to you. Maybe faster. Okay, so the observation. What is the observation? Okay, okay, so if we have Vx is similar to Ix, okay, you get speed up, or we can say we have increasing speed. If Vx different Ix, I mean different direction, we have speed down. or we say decreases bit. Okay, decreases bit. Then now we consider Rx and Vx. So if Rx and Vx have the same directions, we have increasing distance. Okay, increasing distance. And Rx different from Vx. We have decreasing distance. Okay, yeah. So if we just use the observation, okay, you can get the answers, right? Okay, so now check the answers. I hope some of you get the correct answer and then you get some extra point. Okay, now distance with the R here, with the V here, so they have the same direction. So increasing. With the V here and with the A here, they are opposite to each other, so decreasing. Okay, now R and V opposite, decreasing. V and A the same, increasing. R and V the same, increasing. V and R increasing. Different, decreasing, different, decreasing. Okay, so I mean just of course you can use the graphical representation, but we don't have more time. So okay, so you can explain by a graphical representation for yourself, or you can explain by the formulas I just explained to you before. Okay, you also get yeah, the same result. So okay, so just remember just remember some formulas, please. Okay, so we have A E Vf minus Vi over Tf minus Ti, and V E Xf minus Xi Tf minus T. I mean average. Okay, that's all. Any questions so far? Let me see. Are there any questions? Okay, no questions. So we continue. And yeah, and we finish 2.6. Okay, and we have some exercise, but you answer for yourself. I also give you the explanation here. Okay, you can you can rewatch the recording. You can know the answers, and then you can check my reference solution. Maybe I will explain to use just question I think. Okay, so the electric car move airport commuters back and forth, okay, along a straight path from point A to point B, and avoid 2,000 feet away from A. Okay, point zero halfway between A and B. Okay, so here it is 0. So this is A. This is B. Okay, and like this. Okay, I'm lazy to draw. Okay, just use this one. Okay, so we have this is 2,000 feet between A and B. Okay, you know, boy A here, boy B here, A and B, and the boy 0 halfway between A and B. So if here is 2,000 feet, so here is 1,000 feet. Okay, what else? Boy 0 is chosen as the coordinate origin with the direction from 0 to B. Second A is the positive, you know, from 0 to B is a positive. So here must be X. This is positive. Because, yeah, they just mentioned here, you know, the direction from 0 to B. Second is positive, this is positive, this is negative. Okay, so if you understand clearly the information here, you can draw the coordinate like this. Okay, so after that, very easy, you know. After that, if the car is 600 feet from B, 600 feet from B, so the car here, okay, 600 feet from B, okay, and it's moving 15 feet toward B, okay, with its speed increasing at 2 feet per second square. Okay, so what are x, vx, and sx? Okay, so if the car here and the car here, what is it? What is the question B? The car here and move to B. Okay, so the car here and after some time they move to here, right? So if we follow this direction positive, you can make sure VXE positive, okay, AXE may be constant, but we know this is positive, okay, and R will be positive also, okay, so we can determine R. So if here is, oh, my stable should be here, you know, currently, because this is 650, 400 feet. That's okay. So we have here from here to here is 1,000 feet, and here from here to here is 600. So from here is 400 feet. Actually, it's, you know, this one should be shorter, this one should be lengthened. Okay. So this is 400 feet, or we say 400 I overhead. Okay, VXE. 15 I overhead feet per second. This is positive, and AXE 2 I overhead, okay, feet per square second, okay, 2 I overhead. Okay, anyway, it's very easy. Okay, so it's just a question to be for your for your reference. Okay. Now we don't have more time, so we have examples 2.3 also for your reference. Okay, you can answer for yourself at home. We don't have more times. So just skip it. Okay, maybe we discuss this one. Okay, a little bit interesting. Okay, so figure 2.2 show the position x versus times x times, okay, positions versus time, or they say the position is the function of times. So for very luckily they give us the function of position. Okay, yeah, they give us the function because this one like parabole. This one line parabole, so this is the quadratic equation. This is quadratic equations, right? We have quadratic equation. Okay, x is a minus t square plus 20t meter. Okay, so from t is 0 to 15, yeah. Use the calculus to verify the results. Okay, obtain these figures. Okay, they would like to ask us to calculate the instantaneous velocity, you know, the instantaneous velocities. Okay, velocities. So how can we do? Okay, we can calculate Vxa derivative of x with respect to times. Okay, so we can get how many? We can get minus 2t plus 20. Okay, so if we know the function, it's very easy for us. Okay, and then if t is 5, you can get Vx 5 10. T is 10, Vx 10 is 0. And if t is 13, so Vx 13 is 13, so you get minus 20, so minus 6, okay, meters per second. meter per second. Or we can use another method. This is method one. Method one, that means we know the function. We take the first derivative of x with respect to time, you can get the Vx. Okay, method two. If, I remember I mentioned to you before. So if we don't have the equation, so we just have a graph. So how can we do? So you can draw the instantaneous. You can draw the tension line. Okay, you can draw the. So we would like to determine the instantaneous velocity at 5 seconds, right? At 10 seconds, right? And at 13 seconds, right? Okay, so you draw the tension line. Okay, so if you draw the tension line, this one line is slope, right? This one line is slope, and then you just pick up randomly 2 points, point A and point B. So for point A you get 0.25, point B you get A and 105, and then you apply the formula. Okay, well, Vx is xb minus xatb minus ta, so xb is 105 and xa is 25 and tb is 8, right? And ta is 0, you can get 10 meters per second. And similarly, we have the tension line here. Okay, this one is constant, so the velocity will be 0. And we have the last one here, right? Okay, so you just pick up 2 points. Okay, if CE8 you get 121, and if T15 you get 15 and 79, and then you have the formula, right? Velocity, instantaneous velocity is xd minus xc, td minus tc, and you get the same result. So it's up to you. But I mean, for these questions, okay, we have 2 choices. Okay, if we are lucky to get the function, okay, you just apply the calculus, you can get the answers. Otherwise, if they just give us the graphical representation, okay, you just apply the formulas. Okay, actually you just draw the tension line and you just pick up randomly 2 points. Okay, so if you don't like point A and point B, that's okay. You can choose point C somewhere here, T83 and X is 50, and you can choose 7. Okay, here you can get 7 and 90. Okay, and this is 3 and 50, so you can get the Vx5 is 90 minus 50, and this is 7 minus 3. Okay, so for 90 minus 50 you get 40, and this is 4, so you get 10 meters per second. Okay, the same. I hope you understand. So we have any questions so far? No questions? Okay, so if no questions, okay, continue. This one for your reference. Okay, we don't have more times to explain all the exercise. Okay, so I just give you the reference answers, and you need to discuss with TAs. If you don't understand, you discuss with your friends. Okay, the other student. Okay, to get the answers. Okay, so this one for your reference, just mention about for motion diagrams. Okay. Look, this is the velocities, velocity increase. Why velocity increase? Because A and V in the same direction, so you get speed up. Okay, now velocity decrease, the speed decrease. Why? Because v different from a, this is a. Okay, v is opposite to a. Okay, yeah, that's all. And now a is zero. A is zero. If a is zero, does mean the velocity is constant. Okay, constant. The distance equal, right? Because a is zero. Okay, now speed up. So the distance increase. Okay, this is speed down, distance decrease. Okay, yeah, that's all. So now I think we take a break. We take a break. Now we have, let me see, we have 10, 25, and we take a break, and we will come back at 10:35. Okay, yeah. Hello, I'm coming back. Okay. So today, can you see my slides? Okay, continue. So now we discuss session 2.8. Okay, this session is very important, and we have the final exams uh, in relation to this session. Okay, we discuss about the particle under constant acceleration. Okay, so we assume that the acceleration is constant. Okay, so these conditions is satisfied if average acceleration is equal to instantaneous acceleration. Look, in such a case, the average acceleration over any time interval is numerically equal to the instantaneous acceleration. Okay, as any instant within the interval, and the velocity change at the same rate throughout the motion. Okay. Anyway, to be simple for analyzing any physical model. Okay, we normally assume that the acceleration to be constant, or we can say ax equal to ax average. Okay, average. Okay, and because Ax is constant, okay, if Ax is constant, so Vx should be linear. Okay, yeah. So if we have Ax negative, okay, so Vx like this or like this. Okay, yeah, because this left is in the fourth quadrant. This is first quadrant, fourth quadrant, second quadrant, okay, third quadrant. Okay, yeah. So this is the assumption. Okay, assumption. Yeah. So this situation, what is it? This situation occurs often enough that we identify it as an analysis model, the particle under constant acceleration. The particle under constant acceleration. Okay, so now we have this assumption. So if we have the assumptions, okay, so look, Ax is constant, right? Ax is constant, and Vx is linear, okay, and then x should be non-linear, and actually x should be equation, quadratic equation, because Vx is linear, so Vx is linear, so we have x like this, okay, linears and like this, I mean the curve like this, linear equation, or we say quadratic equation. This is zero, of course. Okay, so now we have the conclusion. So xa non-linear, normally quadratic equation. equation. Okay, and Vx is linear, then Ax is constant. Okay, so this is the consumption. Okay, so if we follow the consumption, we have some significant equations. Later on, we will discuss equation by equation. Okay, so now look, as mentioned before, if Vx is linear, x should be non-linear. Non-linear. It depends on Vx. Okay, Vx may be like this. Okay, or Vx like this. Okay, so we have the curve x like this. Okay, so it depends. Okay, it depends. Vx. Okay, you can get x. Okay, yeah. Look, Vx is a linear function, so Ax is constant. Okay. And then so we know Ax average. Okay, Ax average is what? Is Vf minus Vi over Tf minus Ti. Normally Ti is 0. Okay, and Tf is T. So we can get Vf minus Vi divided by T. And here they say X here, they say Vxf minus Vxi divided by T. Why? Because the subscript X lets us know, okay, we follow the straight motion. Okay, we only follow x-axis direction. So we have Ax is Vxf minus Vxi divided by T. Okay, and this is the first equation. The second one, because Ax is constant, so Vx is linear. So this is the equation of velocity, right? We have Ax E Vxf minus Vxi over T. So that means we have, if we modify some things, you can get Vxf E Vxi, right, plus Ax over T. Okay. Yeah. So now, yeah, we have the first equation, right? Okay, we have the first equation. I will write here. I will summarize for you. Okay. So now we talk about constant acceleration model. Okay. So Ax average. Okay. E constant. That means Vx is linear and Xe non-linear, right? Or we say quadratic equation. Okay, yeah. So now we have Ax is Vxf minus Vxi over T, because we say Ti is 0 and Tf is T. So we can get the first equation. Vxf is Vxi plus Ax times T. Okay, the first equation. Okay, then come back. Okay, now we have the second equation. The second equation, we talk about Vx average. Okay, because this is linear. So if here is Vxi, here is Vxf, we get V average here. Vx average here, right? Vx average is Vxi minus Vxf divided by 2. You get average, right? This is Vxf. This is Vxf. This is Vxi. If you take the sum, take a sum of Vxf and Vxi divided by 2, you can get Vx average. Okay, this is the third equation. Okay, yeah. Now we combine. So let me see. Let me remember. Okay. So now we have Vxf is Vxi minus Ix plus Ix times t, and we have Vx average is Vxi plus Vxf divided by 2, right? We have two equations. And we have Vx average is also xf minus xi divided by t. Okay. So from this equation, we have xf minus xi e Vx average times t, and Vx average is here. So now we can get xf minus xi e Vxf plus Vxi over 2 totally times t. You get this one. Okay, and then we move minus xi to be here. You can guess xf is 1 over 2, right? And here you get Vxf plus Vxi times t plus xi. This is here. This is here. Okay. Yeah. So now we have the other equations. Number two. We have xf is 1 over 2 Vxf plus Vxi times t plus xi. Okay, normally we just we move with we say we write xi first and then plus half Vxf plus Vxi times t. Okay, here you have the second equation. Okay, yeah. Number 3, of course, we have number 3. I remember totally we have 5 equations. 5 equations you need to remember. Okay, now we're looking for the other 3 equations. Okay. Yes. Okay. Next one. Let me see. Okay, so now we have xf is xi plus half Vxf plus Vxi totally times t, and we know this one, right? We know Vxf is Vxi plus Ix times t. So I would like to combine this equation and this equation. Okay, so we have xf is xi plus half. Okay, I write here Vxi, right? So Vxf is what? Vxf is what? Vxf is Vxi, right? Minus plus what? Plus Ix times t. Okay, I combine. I can get and then t here. T here. Okay, this is Vxf, right? Okay, so if I combine this equation, I can get this one. And then I modify a little bit. I have xf is xi, Vxi and Vxi, you get 2 Vxi, you times 2, you get Vxi, and then you times t. Okay, and then this is half. This is Ix t and t, you get t squared. You get number 3. Okay. So now I copy number 3. Okay, to be here. Okay, so now we have xf is xi, right, plus Vxi times t plus half Ix t squared. S is number 3. Okay, this is number 3. Okay, continue. Number 4. With number 4. This one, this one, this one. Okay, number 4. Look. Now, we come back to the second equation. We have EF is EI plus half VXF plus VXI times T. We discussed this one before. And you also remember, right? We also remember VXF is VXI plus AXT. So that means TE VXF minus VXI divided by AX. Okay, so if I would like to eliminate the variable T, I replace T here to be here. Okay, so now I guess XF is XI plus half VXF plus VXI, and then T is what? It's VXF minus VXI divided by AX. Okay, this one. And then I continue to modify. So if I move xi here, I can get xf minus xi, right? I move this one to the left side, and then I times 2. So here I get vxf plus vxi. Here is vxf minus vxi. So you get the vxf square minus vxi square. Just the knowledge of high school, right? High school, and divided by ix. And then I modify a little bit. Okay, now I get vxf square. Okay, I move AX to be here. Okay, so I get xf minus xi and 2 here, and then AX, right? And then vxi, I move to the left side, I can get the vxi square plus. Okay, I can get number 4 here. Okay, so vxf is vxi square plus 2xf minus xi. Okay, now right here we have vxf square is vxi square plus 2xf minus xi. Okay, yeah, yes, okay, here plus 2xf minus plus 2ax, right? xf, okay, correct. Sorry, sometimes I don't remember all formulas, you know, so I need to, yeah, but you can demonstrate how can you get the formulas. Okay, then okay, so, and the last one, what is the last one? The last one is what? The last one will be, oh, that's all. Just why I get 5. 1, 2, 3, 4. Oh, this is 4. Sorry, this one is 4, and this one is 5. Okay, so yes, that's all. Okay, so when we let me just show why here I just get 4. Someone remind me, I forgot which one. forgot which one. Maybe it's Vx average E Vxf plus Vxi over 2. Mr. Someone remind me. Okay, so we had a question. I have the question short in slide 2.6, exercise 2.1. Question A, you use the direction of distance and speed to find whether the distance from the origin is in relation or not. Which you put as in recent, but after some points, the instantaneous speed will reduce until is 0, and then have a negative value after some more times. The object will return to the origin. So it makes sense to put distance from the origins as increasing. Let me think. 2.6. Okay, let me back to 2.6. Way 2.6 exercise. Let me see. Exercise 2.1. And then let me see. So let me see the instantaneous speed will reduce until this is 0. And I have negative. Yes, okay. That is correct. So this one is correct. Okay, continue. And after some more times, the object will return to the origins. Okay, that is also correct. So we put distance from the origins as the reasons. Let me check. So here we have the diagram here. So maybe you need to give me more explanation, or you can answer. This exercise and send it to me. I will give you some feedbacks, because I think we need to follow this description of the questions. Okay, so here. We have back and forth along a straight path between point A and point B. This is point A, this is point B. Okay. And from point A to point B, we have 200 feet. Okay. At the point 0, halfway between A and B, yeah, they say the point 0 halfway. E chooses A, the coordinate origin, so the origin should be here, right? With the direction from 0 to B. They mentioned here, okay, the direction from 0 to B must be positive. It's positive, okay? So if this one is positive, so that means here is x-axis and here is y-axis. Okay. And then if the car is 600 from B, I mean, they just mentioned about the distance between the car position and from B. So this is 600 from B, so this is 1000, right? From here to here, 1000 feet. So this one is 600, right? 600 feet. Yeah. And this is moving toward B. Okay, so the car here, and move toward B with the speed increasing. Okay, they just I mean very simple in the question just ask us determine where is x, okay, where is vector vx and where is vector ax. Okay, and you need to follow the questions and you should determine the you should determine here is the origins. Okay, yeah. And of course, if the electric car moving backward, forward, backward, back and forth, okay, you can further analyze instantaneous Vx, okay, sometimes positive, sometimes negative, okay, it depends, okay, but when we stop here, just very simple analysis, okay. Yeah. Other questions? Two boy one. Oh, sorry, 2.1. Okay. 2.1 here. So for 2.1, I think that the key point is origins. Okay, I mean the starting point. The starting point. Or initial point. You know, initial point is very important. Initial point is very important. Okay, this is origins. Okay, this one is origins. This one is origins. So very simple thinking. This is origin. So this is x-axis. Okay, right? This is y-axis. Okay, we don't care about y, just care about x. Okay, yeah. And this is reference axis. If we follow this direction, you get positive. Okay, but now we don't care about this one because we have the observer. You just compare the direction. Okay, yeah. We don't care about V is negative or positive, A is positive or negative. Of course, I mentioned before, you can use the graphical representation and you can assume V is positive in this way because here A origins and A is negative in this way. That's okay. But I mean the quick way, we just compared the directions between two vectors. Okay, yeah. Is it okay for you? Of course, you can further think about different origins, different starting point. That's okay, no problem. Okay, so if you consider here is the origins, it's also okay. It's also okay, no problem. Okay, yeah. Anyways, you can give me some explanation or some answers. I will give you some feedbacks. Okay. Yes. Yes, yeah, you can do that. Yeah, yes, okay. Yeah, we just compare the directions between two vectors, position and velocity, to know the distance, increasing and decreasing, and we compare the velocity and acceleration. Okay, yeah, just just the starting point, just around, yeah, like you said, at the starting point, the beginning times of these objects. That's okay. Okay, yeah. Okay, so I hope you got it, and we continue. Okay, so we come back this one. So what is X? March every velocity versus times with acceleration versus times. Okay, here we have velocity versus times. Here we have acceleration versus times. Okay, so if Vx is linear, Hx must be constant. Vx is non-linear, Hx is linear. I mean, we assume this one is quadratic equations. Okay, and if Vx is constant, sorry, Vx is linear, Ix is constant, Vx is constant, Ix is 0. Okay, so we have A, D, B, A what? Sorry. A, A, E, B, D, and C, F. Okay. Yes, very easy. Just have you uh, remember the relationships between the velocities and acceleration. Now, for summary, okay, we have 5 equations. You need to understand clearly, and we. So if you don't want to understand, sorry, I don't want. If you don't want to remember these equations, that's okay. But you need to remember graphical representation, and then you can get back the formula for yourself. Otherwise, because for the final exams, final exam, you have to teach it. Okay, at least one page. Okay, two pages. Okay, one digit, 2 page. Okay, I mean double side. Okay, so you can add any equation you think they are important, okay, into your digit, and then you need to remember it. So now we have try to understand. Okay, these equation, if you don't understand, ask me. I will explain to you further. Okay, so 1 minute. Think about 5 equation. And I mean, you try to get your observation from this equation, for example. So if some question require us to determine the time, I mean, at the beginning, Ti is 0, right? At the Tf at, so you have Tf minus Ti at like this. Okay, so if the questions require to calculate time, you can use equation 1, equation 3, equation 4. But if the questions require us to calculate xf or xi, you can consider 3, 4. Okay, that's enough. So if the question requires to determine VF and VI, we normally consider this one. Okay, yeah, or this one. Okay, anyway, it depends on the questions. We can select the suitable questions, okay, to get the answers. Okay, any questions so far? Any other questions? I'm waiting for you 1 minute. If no questions, we continue. Okay, yeah, continue. So we have, let me see, we have some examples. I think it's very easy, so I just quickly explain to you. Okay. Now for example, here, this example. A jet lands on an aircraft carrier at a speed of 400 miles per hour. That means 63 meters per second. Okay, so what is its acceleration? We assume that acceleration is constant. Okay, if it stops in 2 seconds, okay, due to an arresting cable that snags the jet and brings it to a stop. Okay, so at the beginning, initial point, we have VI E, look, 63 meters per second, and after T and TI is what? TI is 0, right? And we would like TF AT, right? Now, so how many times? What's the times when the jet stops? Okay, so the time is 2 seconds. They ask us to calculate A, how many? But we know if the jet stops, Vx is 0 meter per second. Okay, yeah. And then you apply the formulas, right? We have Vxf is Vxi plus Isx times t. And at the beginning, velocity is at the final position, velocity is 0. And here you get 63 meters per second plus Isx times 2. So that means you can guess Ix is minus 63 over 2. You get minus 32 meters per square second. And that's correct. Why? Because if the jet would like to stop, Vx different Ix. Okay, so Vx is positive, so Ix must be negative. Okay, very easy. And then they ask us to calculate xf, the final position. Okay, so for example, here this is the carrier, and then we have the jet here. Okay, at here, and then come to here. To this one we have 0. I mean xi, and when the jet stop here, you get xf. Okay. Yes. So we know xi is 0, and then we want to get xf. Okay. So we have xf is xi, right? Plus blah blah blah. Okay. So xf is 0. You get half. Vxi is 63. So Vxf is 0 times t. T is what? T is 2. Okay. So you get 63 meters. Okay, very quickly. So if you can modulize these physical operations of the object, you can apply some equation in relation to constant acceleration to get the result. Okay, any questions so far? Questions? Okay, continue. So, yes, this example. So, when you are driving at a constant speed, 45 meters per second, when you pass a dropper on a motorcycle, it is dropper. Okay. He is behind a billboard. Okay, like a Vietnamese policeman, right? Okay. And then I guess he is measuring the speed of your car. Okay, yeah, it's a funny story in Vietnam. Okay, so 1 second after, that means you already move 45 meter, right? Yeah, because when you pass a double, you are running at the speed of 45 meter per second. So 1 second later, you get 45 meter, right? Your car pass the billboard, okay? The dropper set out from the billboard, okay, to catch you, accelerated at the constant rate, okay? So that means you constant speed and double constant acceleration. Okay, so if you are in the constant speed, that means Vx is constant, okay, and x is linear, right? And for constant acceleration, okay, we know some equation, right? Okay, so we need to analyze your motion and dropper motion, and then after sometimes, okay, yeah, we meet the dropper. Okay, so now we consider the car or your car. Okay, we have Vxa constant. Okay, so we have the equation like this because Vxa constant, so x is linear, so we have xfe xi plus Vx times t. I mean your car. Okay, so we say, yeah, we assume here is the origins, okay? So from here to here, 45 meter, right? Because we are running at 45 meter per second. And after some times, the dropper will catch your car. Okay, so they ask us, what is the times? Okay, so here we say origins and the time is 0. So this the time will be minus 1 second because you choose the origin here. Okay, so you can make sure TA is negative and TCE positive. Okay, so now, so here we say this is TI and this one is TF, or we say this is XI, this is XF, right? So we have X car, I mean your car, okay, your final position of the car, Okay, x car is xb plus vx times t, and vx is 45 meter per second. Okay, now double this is constant acceleration. Okay, so xf double xf is xi plus vxit plus half axt t square. Okay, this is double, and at the beginning he xi is here, right? Xi is here, xi here. So this is 0, okay, and then you get half. You get half axt square. Then we now we for after sometimes for the distance of the droppers and the distance of your car will be equal. Okay, so we can get this equation, and then after some times we can get this one, some modification, you get t, and t is vx car over ax plus or minus blah blah, because we take this square. Okay, so have plus or minus. So we need to choose plus, because if minus, this will be negative. Okay, so if we choose plus, you get t is 31.0 seconds. Okay, 31 seconds. Okay, so that means after 31 seconds, okay, the trouble will meet your car. Okay, that's all. Okay, so you can answer the questions. How long does it take the trouble to overtake your car? Okay. So you should remember a little bit complicated, because the trouble will start here. Okay, and when we consider the time tb, so we have xb, but xb is not 0, because we need to make sure the car and the troubles have the same starting point, right? So xb must be 45 meter, 45 meter, and then you can add here xb is 45 meters. Yeah, you can get the answer. Okay, that's all. And the question so far, I think it's maybe 1 minute or 3 minutes for questions, if you have. So why we don't use xf is x0 plus v0 t plus, okay? Yes, you can do that. Okay, so you can do that. Okay, so we have but let me see. For the first example, x is x0 here, right? This is here. The same, xf axi, yeah, plus vxit plus half, right? Oh, you mean why we don't use this one, right? We don't need. Why? Because the v for the car, vx is constant. That means ix is already 0. is 0. But of course, you can get more thinking. We just say we can apply the same constant acceleration for both for your car and your dropper, and then for your car, because Vx is constant, so Ax is 0. That's okay, no problem. Here, but if we follow the information from the question, they say constant speed, so Ax is 0, so just skip it. Okay, is it clear for you? Uh, 2.8. 2.8, let me see. Here, you mean why we don't use? Yes, you can use. Yes, you can use. Anyway, you can use. You can use xf is xi plus v xi t plus half is x t square. Okay, so Vxi is 0. Okay, and we have Vxi is 63 times t how many? Vxi 63 times 2 plus Ix is minus 32 times 2 square. Okay, yeah, you can use. I mean, I mentioned before, you can use any information including t. Including xf. Okay, you can use this one or this one. But if you use this one, I mean, you take a little bit more time because we need to consider Ax. But that's okay. You can use it, no problem. Yeah, I emphasize. I mention again, no problem. Okay, 53 times 2 and dt 2, so you get minus 64, right? Yeah, right. 64. So is yeah, it's nearly 63. Okay, the same results. No problem. Okay, it's up to you. It's up to you. No. Okay, no problem. Okay, you can do that. Okay, so is it still for you? Yes. Correct. But if you this one to be careful because X is negative. Okay, and then you make sure you get the correct answers. Is it clear for you now, Minh Thắng? Okay. Yeah. So we try to use the easiest way to get the result. Okay. Otherwise, you need to make sure the reverse answers you get the correct answers. Okay. Otherwise, you get the failures. Okay, in sequence. Okay. Okay. So if you have further questions, okay, don't be shy. Just ask me, and I will explain to use in more details. Okay. Yes, then let me see. This one for your reference is, I think it's easy. Let me see. Do I need to explain to you? Yeah, okay, just a little bit. Okay, so now we can use calculus to calculate velocities. Okay, according to acceleration. Okay, so we know Ax is constant. Ax is constant. So we know the formula Ax is dvx over dt. So when we calculate Vx, we take the iteration, right? So we have, if we move dt here, you get dvx e ax dt, right? And then we take the iterations of both sides. You can get Vx e, what is it? Oh, this is I actually, okay. My writing is very early, so okay. Okay, so now you get Vx is iteration of Ax dt plus c. You know, we need to consider c because what's the meaning of c? C mean initial condition. Initial condition, you know. So if come back to the high school theory, when we calculate any iteration, we also consider initial condition. Okay, initial condition. Normally, it's, for easy when we calculate the iteration, the c is zero. But now we cannot assume that. Okay, so we just say c initial condition of the vx. Okay, or here is vxf. Here is vxi. Okay, yeah. So now we can get vxf is vxi plus Ax times t. Because this iteration, I mean, if the Ax like this, you know, Ax like this, okay, like this. So when we take the iteration from ti to tf, that means the distance, right? The distance, okay. So if delta t is very small, okay, you can get the areas is very small. The areas, right? Yeah, the areas is the delta t. Okay, so like this. Okay, so if we take the instantaneous, I mean instant times, you can get Ax times t. So finally, you can get Vxf is Vxi plus Ax times t according to calculus. Okay, calculus. Then if you let t is zero, because at the beginning, initial condition t is zero doesn't mean we have vxi, okay, is Ax times 0 plus c. Skip it. So vxi is c, or we say c is initial velocity. Okay, just let you know when we use the calculus theory to explain about acceleration velocity or position. Okay, just for your reference. And then similarly, we have x. Okay, so we have x is the iteration of vx dt plus c over comma c prime. Okay, what is c prime? C prime. Okay, so here look, we have vx is vox or vxi the same, you know, because different textbooks, some textbook they use vxi, some textbook they use vox. Our mean initial. Okay, and sometimes they use vxf, and for this textbook they use vx. Okay, and that is the reason when I make the lecture, I introduce to you some different textbooks. Okay, so here you replace into here, you can get vox plus Axt dt c prime. Okay, prime. Okay, so here you can guess within the interval you get x is vox times t Axt raised Axt square over 2, right? Okay, plus c over, what is x? C over comma mean x0 or xi, and x or xf. Okay, so similar, you know, we have xf is xi plus vxit plus half Axt square. The same. Okay, so yeah, we can use calculus. And then if you let t is 0, okay, so t is 0, we skip this one, you keep this one, so x0 is c over comma. So that is the reason I say c prime is xi is xi. Okay, that's all. Yeah. Okay, so anyway, so if we use another textbook, they also have 5 equation, you know, 1, 2, 3, 4, 5. Okay, finally, we have 5 equations in relation to constant acceleration. Okay, this exercise for let me see, do I need to explain to you? I think yes. Yeah. So what time is it? Let me see. Let me check what time is it. Now, maybe we study 10 more minutes, and then today I will explain to you. Okay. Yeah. If you have any questions, okay. So any questions so far? So we have one questions. So whenever the velocity is constant, acceleration is zeros, that right? Yes, 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 yeah, correct. Okay, because we just think about the calculus, we take the derivative of Vx with respect to time. So if Vx is constant, velocity is constant, Ax will be 0. Okay, that's correct. Okay, yeah, sure, sure. Is it clear, Đăng Khoa? Yeah, he left. Okay, so continue. Oh my God, we cannot finish. Okay, so we have many opportunities for you to get actual about. So I remember next week. Let me see, next week we have any class next week. So next week we have holidays, for New Year holidays. So no class anymore. So and then see you New Year, right? 5, 6, 7. Okay, 8. Okay, it's 8th of January. Okay, yeah, and I will. Yeah, we will study on site. Okay, yeah, all right, yeah. On that date, I already come back to VGU campus. Okay, and maybe here we study some physics. Okay, because up to now we only study 6 classes. So maybe in the morning we study physics, and in the afternoon we study linear algebra. Okay, yeah, I will modify it. Okay, please regularly check your timetable. Okay, the timetable in Google Excel. Okay, and I will update information to use also in the VGO Moodle. Okay. Okay, continue. So this example. Okay. So this example with let me see what this is. Okay, we have a rocket. Okay, we have a rocket. Launched from the rest at the rocket. Okay, at ground level. Okay, rise vertically and reach a speed of very high speed, 2.5 kilometer per second at a height of 30 kilometer. Okay, so to be careful, this one also a straight motion, but we follow a vertical axis. So this one is origin, right? This is origins. So this one is positive, and this direction is negative. Yeah, remember that this is positive, this is negative. Okay, yeah. Assumed the acceleration of the rocket to be constant, determine that this acceleration at the time required for this portion, okay, of the flight. We determine the acceleration, but now we say AY, right? Because we follow y-axis, not x-axis, right? Okay, and we need to calculate the times, how much, how long, okay, how long they get Okay, how long they get to this position. But we know the distance from here to here. So this one we say step one. We say this is initial position, right? And here this is final position. Okay. Yes, I think yes. Okay. Final positions, initial position. Then they give us the information of velocity at the beginning. No, because the beginning v0y or vyi is 0, and vyf is xi xf. Now we have yi yf is how many 2.5 kilometer per seconds. Okay, so now we have vxy, we have vxf. So and then at the beginning yi is 0, and at the final position yf is how many 32 kilometers. So we know yi, we know yf, right? Actually, we know yi, yf, vxi, vyi, vyf. Okay, so we can apply the formula here, right? We have the formulas. What we have, vxf square is vxi square plus 2ax. Okay, no, and here we should use y, not use x. vyf vyi, but 2ay yf minus yi. Okay, yeah, we can guess ay, right? Ay, and then because the object is moving upward, okay, upward, so ax, okay, ax is positive, right? Ax is positive because the object is upward. Okay, so finally you get ay is 98 meters per square second. Okay, and then we can, based on this formula, because we know ay, we know vyf is vyi plus ay times t, and we know ay, we know vyi is 0, vyf is 2.5 kilometer per seconds. You can get you can get time, the time. Okay, the time is positive, should be positive. Okay, so you get the time is 20 seconds. Okay, and then we have some exercise for you to practice. Remember, we have reference answer here. Okay, so don't worry, we have reference answers, and then when you do the exercise, you can double check with your reference answers. Okay, and we stop now. And okay, Lee, you need to review, and next 2 weeks we study physics, and we have some, are there any questions? Yeah, we have some examples, some for multiple choice questions. Do we have multiple choice questions? Let me see. Yes, we have multiple choice questions. Okay, so we have a lot of change. Okay, to let you get some extra points. Okay, and next week, sorry, next lectures we will finish these lectures, and then we come to, let me see, we come to lecture 2, part 3. Okay, now the time for TA. Okay, if you have any questions, you can add to TA from 11:50 to 10, 20 and 10. Okay, 20 minutes. And in the afternoon, we have the lecture of linear algebra. So we study a little bit late. Okay, we start to study a little bit late. So we start from 1:10. Okay, p.m. Yeah, enjoy your lunch and yeah, see you in the afternoon. Now the time for today, please. Okay. Remember, yeah. Remember that in the afternoon we study at at 466. Okay, and then we have the link. You can choose Google Meet. So today, please. Okay, in the afternoon you can join. You can use this Google link, or you can use the link we used before. Okay, no problem. Yeah. Goodbye.